Okay, so previously we did for light refraction, chapter 4, chapter 5 form 4. Now still chapter 5 form 4, but now it's for how to draw the light ray diagrams. So light ray diagrams, I'm going to cover concave mirror, convex mirror, convex lens and concave lens. So yeah, you need to remember every mirror has its own and see, for convex lens I'm going to draw this side and see, the lenses I'm going to cover after this. So yeah, let's start with a concave mirror, concave mirror, concave mirror. Okay, yeah. So light can come from any type of position. Light can come at infinity, more than 2f, at 2f, between 2f and between f and I'm going to between f and 2f. This is distance. Yeah, I'm going to put L. I don't really know the letter that they denote distance of light with, but I'm going to use L. Though it's not actually L, just I'm going to use L for this one. L and then L at F and then L lower than F. So for concave mirror, each of these will have different type of results. So I'm going to draw and show you how. So okay, so look, this is concave mirror. I'm going to draw the F here and then C here. So always remember light. So always remember light ray, when they pass through F, when they hit the mirror, they have to go parallel. I'll draw it over here. When they come over here, when they hit the F, they have to go like this, straight. Whereas if they come through the C, when they come through the C, they have to go back in the same direction. They have to go back to the same direction. If F comes like this, go like this. If like this, come like this and go like that. That's how you're supposed to draw it. C, if when light goes through C, go back in the same direction. If F, go parallel. Yep. When light goes through C, go back in the same direction. When it goes through F, we go parallel. So yeah, let's look. When light is at infinity, will always come like this. Light is infinity. Let's take sunlight. Sunlight. Sun is very far from us, so we consider it. It's not actually infinity. It's just very far, but we consider it infinity. It's really far, more than few million kilometers, but we consider it infinity. So when the light comes, it will come like this. The drawing is not perfect, but bear with me. And then go straight like this, like this, like this. I'm drawing without ruler, so bear with me. And then when it comes like this, it will come like this, and it will first it will come like this, and then it will go back. Okay, it will go back. So this is how light ray works. If object is at infinity, image. If object is at infinity, if L equals to infinity, then image at F. The drawing is not perfect, but image should be formed around here. That's all you need to know. The light comes this way, goes straight. Comes this way, go back, and then wherever they intersect, that's where you need to draw a line, and voila, you got the answer already. My drawing is not perfect, so I'm not getting F, but if image at infinity, if the object at infinity, then image will be at F. This is concave mirror. Okay, concave mirror. Next is for next is C. Okay, next is image more than 2F. C equals to 2F. So if more than C, 2F means more than C. So let me put one object here. So this is the object. So what I said, if it is at, if you need to draw one line to the F and one line to the C. So draw one line to the F, then go straight, then draw one line to the C. Okay, that's not perfect. Okay, and then come like this, go like this, go like this. So, if object more than 2F, if object is more than 2F, they are supposed to form at, if L is more than 2F, then after will be a, then image at F to F. Okay, look, when object at infinity, image must be at F. When object at more than 2F, image must be here. So you can see that when this object, when the object is here, image will be at here. When object is at here, image will be at here. When object is here, definitely image will be at here. Then after that, when object is here, image will be at here. Object is here, image will be at here. So they swap position every single time. That's why you need to know lah. And the characteristics of the object, characteristics of the object. So yeah, it is. This one is the band from Soho Tuition Toddlers. So yeah, it's his formula. There got 6 types of characteristics. There are real, virtual, real, inverse, upright, inverse upright. I'll tell in Malay as well. Nyata, maya, tegak, and then after that Songsang, tegak, Songsang, then after that diminished, then magnified, besar, kecil. So yeah, so I'm going to design formula in English. So Malay you can just remember and just you swap out the name. So if object at infinity, image will be rig. Rig means real, inverse, diminished, and image will be formed at f. If object more than 2f, then rig, same thing as this, rig, and then if object at 2f directly at c means rig, ris, because you can see here why object at more than 2f real, inverse, diminished is because it's over here. Right, you can see it's Songsang, this one is tegak, this one is Songsang, this one is big, this one is small, and this one is if mirror, if the image, okay, I draw one line here. This is paksi, this is negative, this is positive. For mirror, if your image is a paksi negative, it is real. If your image is a paksi positive, around here, it will be maya, which is virtual. For mirror, concave or convex mirror, if at paksi negative, it is real. If at paksi positive, it is image. Because mirror, when you see with the mirror, you always want to see yourself. So imagine, if you want to see yourself, you always need to be in the positive side. You shouldn't be in the negative side. Okay, that's all you have to remember. Mirror, if you want to see yourself, just imagine you want to be in the positive side. You never want to be in the negative side. That's all you have to remember. And then continuing, the characteristics. This is the characteristics. Rig is real, inverted, diminished. Rig, real, inverted, diminished. Or an object is at 2f. That means directly at C, it will be real, inverted, same size. I'm going to draw and show you the picture right now. Real, inverted, same size. All you have to do is make sure your line goes like this at F, and draw one more line at C where it comes straight and go back in the same direction. Nothing else. You don't have to remember anything else. And then F C. Okay. FC, when object is directly at C. At C. Okay, I'll draw one arrow here. Okay, when object is directly at C, you'll see that the object will be a bit close to C because my drawing won't draw accurate. So I'll draw start. Go to F, become straight. Now you have a problem. How does the light go to C? That's what we'll be asking. So there are one more technique. If light goes to F and goes straight, if light goes straight, logic will go back to F. So you can see, light, if go to F, it becomes straight, it becomes parallel. That means if the light is parallel, it will go back to F. That's how it always works. So that'll go to F, go like this, go to F, go like this. Then after that you draw one more like this and you go like this. That's all. Then after that you have an image here. The image is same size, but my drawing not that good, so it's smaller. But I say what? Real inverted same size, and then I show you what? If object at a 2f, the image should also be at 2f. If object, if L equals 2f, image at 2f. That 2f. You got the answer already. And after that, for this one, yeah, I'll show this one. And it's still real because object form at Parksy negative Parksy. That's why you don't want to be negative. You always want to be positive, and you want to see yourself. So if you're negative, immediately know it's always real. If you want to always be positive, you must see yourself. So if object at real, you need a screen to see it. Else if object in virtual means you can see yourself just by looking at the mirror. And if you always want to look at the mirror, you want to look positive, right? So just remember, Maya must be positive, real is negative. For mirror, lenses, it's opposite. If you remember mirror already, lenses you can automatically know. When Parksy negative, it's Maya, and Parksy positive, it's real. For lenses, not mirror. If mirror, negative is real, positive is Maya. Outside the mirror, outside the negative Parksy is inside the mirror, Parksy positive is outside the mirror. Outside the mirror is Maya, inside the mirror is real. That's all you have to know. And then after this, F. So F, C. So I draw one image here. Okay. Go like this. Go like this. You might be thinking as well, what am I supposed to do here? I can't go through C as well. That is why you always use this. There is a second method for a reason, and there's a second method for a reason. My drawing isn't good, so that's why, and my scale isn't that correct. That's why it's a bit weird. When you draw like this, you bring to F, and then your image will be more than C. Will be more than C, or 2F. So if equals if F to F, image okay, to F, yeah, that's all. Go like this, go like this, go like this, go like this. That's all. And now for this one, an object is at F. An object is at F, and then C. F and then C. So an object is at F. An object is at F. So what you do? You bring straight line, you go like this. The thing is, you can't bring a line downwards. You can't bring the line to bawah because you are at F. Whereas this one I showed, if line is line you want to bring down to F, but this one you can't bring down because it is at F. So what do you do now? Very smart idea. Go like this and go to C. That's all. Go straight, go back. Go like this and go like this. That's all. you go straight, go here, and if no other choice, you go up and you go back to C. Because if like this, if go through C and it goes back means when it comes here, same thing happens lah. Same thing. When it goes like this, it goes back to C. Because when it goes to C, it has to go back. So you just reverse psychology, go like this and come back. That's all. Then become parallel. If parallel means object image at infinity. If your ray is parallel, that means image at infinity. Yeah, that's all. If your ray is parallel, that means image at infinity. And after that, yes, this one, image below F. Image below F. But convex lens, I'm only going to show one contour because convex lens nothing much. You don't have. It's only one result will come out. Nothing else will come out. For concave mirror, there was 6 type of position, whereas convex mirror, any position will get you the same type of image. So yeah, I'm only going to do one contour for convex. And then you go like this, F, and go like this, C, and I put one image here. Put one long image here. Yes. Oh. Okay, so yeah, I actually forgot how to do this, so I have to see the book. Yeah, okay. So if image at F, yeah, pa. Yeah, wait, come in. If image at F, bring a light ray, go here.
Easy,
I'm making video. And then you make one here and then bring straight to F. Okay, you can see the light rays are moving far away from each other. Where do you go now? You can't go anywhere, only one place. You go to positive side. Okay, when positive side, remember when you're going inside the mirror, you need to draw dot line. Dot line. So when you draw dot line, your image will be formed over here. Your image will be formed in the Paxi positive, which means your image is Maya. Maya means virtual. That's all you have to remember. And it goes like this, you got no other place to go because this one, the distance between this and distance between this, you can see difference. This one is bigger than this one. So this one going away means this one the only place you can go is inside here. That's all. So you draw one straight line there and voila, you got the answer already. If but this one I cannot do if because when image is below F, if object is below F around here, image can be anywhere inside the in the Paxi positive. You cannot go anywhere. That's all. So yeah, that's all. Now for convex mirror. Convex mirror. Convex mirror, convex mirror, the image will always be Maya. Convex mirror, you have to remember, image always Maya, and then image will always be Maya. And wait, I'll draw it out for you, then I'll explain. I can erase this and solve. Read, wrist, ring, womb. When object at infinity, image will be real, inverted, diminished. That means real, which is nyata, inverted, songsang, diminished is kecil, will be lebih kecil. Same thing for object more than 2f. When object is at 2f, real, which is nyata, inverted, songsang, but same size. Yeah. That's just same size, summer size. S only for when object is at 2f, no other places but. Then when object is between f and 2f, ring, which is real, inverted, magnified, the object will start to get bigger. And then when object is at f, it will be virtual, upright and magnified. It will be virtual. Yes, it will be virtual because infinity, if image is infinity, it will always be virtual. And it will be magnified because if infinity, it will go a really long way. So it will definitely be bigger. And then upright. And then for smaller than f, you saw yourself, the image will go to part C, positive, it will be upright and it will be bigger. So you know the detective lenses that people all see, they see like that with the book, the letters appear bigger. Yeah, that's convex. No, that's convex lens. Sorry. But in the shopping, where in the 99 speed model, you can see the big ass mirror at the corner where they use the mirror that looks like coming out. So that one makes the things look bigger and upright so that people can see if someone's trying to steal or not. And now, read, just remember, read, wrist, ring, womb. Read, wrist, ring, womb. That's all. So now it's not concave, it's convex mirror. Convex mirror like this. Convex mirror like this. F, C. Okay. Convex mirror, same thing. If parallel, must go to F. If parallel, since this one is since this thing like moving outwards, whereas concave like moving inwards, ke dalam. Convex is like moving outwards. If moving outwards, you should know light goes like this, straight to F. Light moves out. Light goes like this, goes like this. But you need to remember, if light goes out, that means it will never meet. And wait, let me draw finishes, then I explain. Light goes like this, after that like this. After that, and then one more. Yes. Okay. Yeah. I'll draw with image one. I'm doing an infinity. straight. Then after that, it will go straight. Then it will go like this. It will go like this. Same thing. If concave mirror, light come this way, will go like this. Light come this way, will go like this. Same thing. Light come this way, will go outwards, or light come this way, will go this way. All same. Same like this. Come this way, go this way. Come this way, go this way. The same thing. And then one more is C. And then you go like this. Okay. So now, if like that, shit, I did something wrong. A very big mistake. Cut that out, Google, cut that out. Which part is it? At 31. Okay, again, I'll draw image, I'll draw F, I'll draw C, I'll draw like this and I go out, and after that I draw towards F and I draw like this, and then I make the dot line, dot, I draw like this. So you need to know, if in positive part C, you have to do dot line. If negative part C, you need to do normal line. So you can see, when I draw straight, I draw towards C. Then I patah balik. Then after that, when I draw straight line, I go like this, but there is an dotted line inside the mirror. You draw the dotted line and voila, you got the answer. Just do this. Draw one towards C, one towards like this, towards like that, and draw one dotted line inside F, towards F. That's all you need to remember. And the image will always be virtual, upright, and diminished. I think that's all. Yeah, virtual, upright, diminished. The object will always be smaller, it will not be bigger. Oh yeah, that's all. Thanks for watching.